Good morning, children. Welcome to the computer class. This is the second part of chapter number 13, Data Structure. So, in this video, we will be learning about queue, what is queue, DQ, and address calculations. Okay, so let's start. So my first topic is queue. So queue means it is a linear data structure which is used simply as a single dimensional array. Okay, it is similar to the stack. Stack is also a single dimensional array or a linear data structure. Queue is also a linear data structure which is used simply as a single dimensional array. But there are some restrictions. Okay, it's follow the FIFO nature. Where the stack follow the LIFO nature and queue follow the FIFO nature. FIFO means first in and first out. It is also known as FCFS method. Okay, FCFS, first come and first serve. So it means that the element which has entered the queue first will come out first. Okay, and a queue contain two types of pointer. First one is front end and second one is rear end. Front end and a rear end. Front end pointer point the data which can be deleted when if required. Front end means where the data which can be deleted, and rear end pointer point the element which is inserted last. So overall we can say that rear end where we deleted the data and front end the point where we insert the data into a queue. Now the next topic is operation on stacks. Operations on stacks. So basically there are two types of operation can be performed with a queue. First one is insertion and deletion. So insertion means, as the name suggests, it is an operation to store an element in the queue. Store element in the queue. So if now the condition for insertion is if rear is equal to n, where n is the size of queue, then no more element can be inserted into the queue. So this situation is known as queue overflow. Queue overflow means if rear is equal to n. Okay, so this situation is known as queue overflow. Next one is deletion. Deletion means to delete the data or an element from the queue. Okay, so delete an element, first of all perform deletion and then increase the front end pointer by 1. So the condition for queue underflow is if front end, okay, if front is equal to null. It means there is no element available in the queue. If front is equal to null, it means there is no element available in the queue. So this situation is known as queue underflow. So there are two basic conditions for queue, insertion or a deletion. For insertion, we can check that queue overflow condition, and for deletion, we can check that queue underflow condition. Right? Okay. Look at this example of front end or rear end or a insertion or a deletion. How to insert a data and delete a data in a queue. So this is the queue. Here the front is equal to null and rear is equal to null. Now in step number 2, insert the element 5 into the queue. So here the front is equal to 0 and rear is equal to 0. Now when we insert the element 8 into the queue, now the value of rear is 1, okay, and the value of front is 0. Rear for insertion the data, front is used for deletion the data. Now the insert element 12 in the queue, so now the value of rear is increased by 1 and the value of front is 0. Next, delete an element from the queue, okay, delete the element from the queue. Now the delete this element, because you know that the queue work on FIFO operation, first in first out, okay. Now the value of front is 1, it means the one item will be deleted, and the value of rear is 2. Now next we can insert the element 25 into the queue. Now the value of rear is 3 and the value of front is 1. Finally, we can insert the element 31 into the stack. So here the value of rear is 4. Okay, so here the rear is equal to n, means the size of queue is equal to rear. So this insertion is not possible as queue overflow. So this situation is known as overflow. Okay, when we delete an element from the queue, so finally if front and rear pointer point the same element, there is only one element available in the queue, delete the element from the queue. And finally no element is available in this queue, so it means this situation is known as queue underflow. So I hope you understand what is an queue or how to insert or a delete element into the queue, right? Now the DQ means it is referred as a double-ended queue. Double-ended queue in which insertion as well as deletion can be performed at the both side. Okay, it is different from the simple queue or a circular queue in the aspect that is has both the ends open from insertion and deletion. Okay, it has also two types, front end and a rear end. Okay, so DQ means where we insert as well as delete, insertion and the deletion can be performed at the both end, right? Now the important topic is address calculation, and 2 marks questions always be asked in the board examinations. Okay, address calculation, this is the important topic. So address calculation means you know that linear data structure is the logical structure created in memory to contain data linearly or sequentially. So such structures are array, stack, queue and so on. Okay, so here the number of bytes occupied in the memory by element of array depend on the type of data it's contain. Suppose that I have taken the data int, so it means int data type take 4 byte. Okay, char data type take 2 bytes. So it means the number of bytes occupied in the memory by element of array depend upon the type of data it's contain. So hence to manage the memory efficiently and accessing the data properly from the array, it is must to know the physical address of an element that is stored in the array. So that's why address calculation is essential in array. Okay, so you know that array, the two types, single dimensional array or a double dimensional array. So first one, so address calculation in a single dimensional array. Okay, how to find the address in a single dimensional array? So let the array be ARR, the address of element ARR is I, can be calculated as, look at this formula, address B plus W I minus L. This is the formula for finding the single dimensional array, address of a single dimensional array, where B is the base address, W is the word width, word means the number of bytes an element contain in the memory, I is the index or cell number, okay, whose element address to be calculated, and L lower boundary or a lower index of the array. Okay, And look at this, some number of bytes contained by element in the memory. So you know that character data type take 2 bytes, integer data type take 4 bytes, float data type take 4 bytes, long data type take 8 bytes, and double data type take 8 bytes. Okay, so this is the formula for a single dimensional array. Now the question is how to calculate the address of a double dimensional array. Okay, so in double dimensional array, children, the orientation of element can be row wise or a column wise. Okay, the address of element can be different as per orientation of the element in a double dimensional array. So there are separate system for calculating address in row major wise form and a column major form orientation, right? So first one is row major orientation. So look at this formula for row major orientation. ARR ij b plus w n I minus r0 plus j minus c0, right? So here b means this is the base address, w the word width, j stand for row subscript of the element, I row subscript of the element, j column subscript of the element, r0 is the lower range of row, c0 lower range of column, and n is the number of columns, right? So here n, this is the n. So this n is the number of column, remember that. Okay. Now the column major orientation. So column major orientation, it is similar to the row major orientation. This formula is similar to the row major orientation, but the difference is only here we use n means number of columns. So here in column major orientation we use m. M means this m is the number of rows. That is only difference between row major orientation formula and a column major orientation, and all other things are same, right? So I hope you understand how to calculate, okay, row major orientation and column major orientation for a double dimensional array. Okay, these are the formulas only, and this is the formula for a single dimensional array. Okay, so in the next video we will be discussing about, okay, how to calculate, okay, the physical address, okay, using for single dimensional array or a double dimensional array. Okay, so thanks for watching this video. Thank you.